Hello all. Let's see how to solve numerical questions on ultrasonics. First, we'll do the revision. Already I have shared one video related to the ultrasonics. In that, we people have seen ultrasonic waves are produced by two methods, piezoelectric method and magnetostriction method. The frequency of ultrasonic waves using piezoelectric method will be calculated with the formula F is equal to 1 upon 2t under root y by rho, where t is the thickness, y is Young's modulus of the quartz crystal used in the piezoelectric method, and rho is the density of the quartz crystal. If we talk about the magnetostriction method, then frequency calculations are done with the formula F is equal to 1 upon 2L under root y by rho. If you see, both formulas are near about same. In place of this T, here the parameter L is used, which is nothing but the length of ferromagnetic rod. Then in the theory video, we people have also seen the frequency of the oscillatory circuit could be calculated with the formula F is equal to 1 upon 2 pi under root L1 C1. Here L1 is nothing but value of inductance, C1 is the value of variable capacitance. And one more formula we have seen which is related to the applications of ultrasonic waves, where distance calculations are done. Like if you want to calculate the depth of sea, then that could be done with the help of ultrasonic waves, and for that purpose we are having a formula d is equal to half of t into v. Here t is nothing but total time period required for the ultrasonic waves for their travel, and v is the velocity of ultrasonic waves through medium. Now let's see one formula which is related, one problem statement which is related to the frequency calculations with the help of piezoelectric method. So here the fundamental frequency of the quartz crystal of thickness 1 mm is vibrating at resonance is provided. Young's modulus and density is also provided, means you are having the value of t, y and rho, and here it is asked to calculate the frequency. You may see the given data is provided, Young's modulus is given, value of rho density is given, t is equal to 1 mm. We are going to convert it into meter, and here it is asked to calculate the frequency. So for the frequency calculation, we know there is a formula F is equal to 1 upon 2t under root y by rho. Now put the values into the formula. T is nothing but 1 millimeter, which is nothing but 10 to the power minus 3 multiplied by 2. Value of rho is 7.9 into 10 to the power 10, and density is 2650. Now do the calculation, you will get the answer. F is equal to 2.733 megahertz. Now let's see another problem statement. Here the natural frequency of pure iron rod is provided, which is 40 millimeter. Density is also given for iron, which is nothing but 7.25 into 10 to the power 3 kilogram per meter cube. Young's modulus of that iron rod is given 115 into 10 to the power 9 Newton per meter square. And it is asked that can you use this magnetostriction oscillator to produce ultrasonic waves? So we have to check that by calculating the natural frequency of the iron rod. So here you may see given data is provided. We are going to convert that millimeter length into meter. So that will be 40 into 10 to the power minus 3 meter. Formula will be used here is F is equal to 1 upon 2L under root y by rho. Put the values into the formula, do the calculation. You will get the value of frequency as F is equal to 49 kilohertz. As the frequency is greater than 20 kilohertz, we can say this rod could be used for the production of ultrasonic waves by magnetostriction method. Now let's have some one statement related to the distance calculation. So an ultrasonic sensor emits a pulse towards a wall and receives the echo after 0.02 seconds. If the speed of sound in air is 340 meter per second, calculate the distance of wall from the sensor. This is the problem statement. You can see the given data is T, total time period is given, V is also provided, and asked to calculate D. Formula is very simple, so you can remember D is equal to half of T into V. Put the values into the formula, do the calculation, you will get the answer. D is equal to 3.4 meter. It means the distance of wall from the ultrasonic sensors is 3.4 meters. Now the last statement we are going to see for the frequency calculations of the oscillatory circuit, where we people have seen the formula is related to the inductance and capacitance value. So here you may see the problem statement. An ultrasonic generator uses an LC oscillator circuit with inductance of L is equal to 2 millihenry and capacitance of 500 picofarad, and it is asked to calculate the frequency of the ultrasonic waves produced by the oscillator. So whatever are the millihenry and picofarad values, we have converted into the SI unit. So millihenry, 2 millihenry is equal to 2 into 10 to the power minus 3 Henry. C is equal to 500 picofarad. So we have rewritten it as 500 into 10 to the power minus 12 farad. And here it is asked to calculate frequency. Now let's see. The formula is F is equal to 1 upon 2 pi under root L1 C1. Put the values of L1 and C1 into the formula. Here simply 500 multiplied by 2, that will be 1000, into this 10 to the power minus 3, 10 to the power minus 12, that will be 10 to the power minus 15. 10 to the power minus 15 into this 10 to the power 3 will remain as 10 to the power minus 12. Under root 10 to the power minus 12 will be 10 to the power minus 6. Bring that minus 6 from denominator to numerator, it will turn to 10 to the power 6 and the remaining factor will be 0.159. So ultimately you will get the frequency as 159 kilohertz. So like this you can solve the numerical questions related to the ultrasonics. If you are having any kind of queries, put that into comment box, and thank you for your patience listening. Thank you very much.